Hi guys, so today we will go over number systems and we will be focusing more on rational numbers. Right, so let's start with number systems. Now here we have a number line, right? And let us suppose you are here at the top and you start walking towards your right and start picking all the numbers, right? All the numbers. So when I start in this way, I will pick 1, I'll pick 2, I will pick 3, 4, 5, and so on, right? So these numbers 1, 2, 3, 4, 5, and so on are called natural numbers, right? So we are walking that way and we are collecting all the numbers. Cool. Then we forgot to get 0. So we came back. So now I'm coming back and I will collect 0. So when I collect 0 along with all those numbers, so now I have 0. And then I have all those other numbers that I collected previously, which is 0, 1, 2, 3, 4, 5, and so on. When these numbers are all put together in a bag, they are called whole numbers, right? Then I have collected the numbers from one side, from my right side. I'm standing here again. Now from here, I thought of, let's go to the other side and see what I find. So I started going to the other side, and what I found was I found some negative numbers. So I started collecting those. So I collected -1, I collected -2, -3, -4, or -1, -2, depending on what you want to say. So I collected those numbers and I put it in the same bag. So now my bag has 0, 1, 2, 3, 4, 5, and so on. And I also have -1, -2, or -1, -2, -3, -4, and so on. So my bag is now full of negative numbers, 0, and all positive numbers. And this is called integers, right? So this is called integers. This might be a new word for some of you. And then I thought I collected everything from the line that I was walking on. But no, now when I have taken all the numbers out, when I have taken all these numbers away, what I saw was there are still numbers in there. It was half. It was some other number here, 3/2. There was another number here, 5/2, right? There was 1/4. It was -1/4, -half, right? There were so many numbers there that I have not collected yet. So then we started collecting those numbers along with the numbers that I have. So I had 1, 0, 1, 2, 3, 4, 5. I had -1, -2, -3, -4. And then I got some more numbers which lie in between. So I had half, I had 3/2, I had 5/2, I had half again, -half, -1/4, -3/2, and so on. So these numbers that can be expressed as, so let's write down numbers that can be written in P/Q form. So P/Q form is something over something, where Q is not equals to 0. So we cannot have the denominator as 0, right? So for example, we can have 1/2. So P is 1/2. Q is 2. You can have 3/1, which is equals to 3. So a number by itself, a whole number, a natural number, or an integer can be written as a rational number as well, right? 100 over 715. Any number that can be written in the P over Q form is a rational number. It's called a rational number. And rational number includes everything that's in your bag so far. So your bag has integers, your bag has whole number, and your bag has natural numbers as well. So a collection of all these numbers are called rational numbers. Right? Now, next, let's quickly go over a few questions just to clarify. So let's see if these statements are true or false and how well have you understood. So every whole number is a natural number. Yeah, think about it. Every whole number is a natural number. So whole numbers are 0, 1, 2, 3, 4, and so on. Whereas natural number starts from 1. It does not start from 0. 4 and 5. So are all whole numbers natural numbers? No. So the answer is no, or you can say false. Right? So it's false because 0 is not a natural number. All right, next statement. Every integer is a rational number. Every integer. So integers are -2, -3, -4. We can have 0. We can have any number 1, 2, 3. So any number that's written here is integers, right? So are these integers rational numbers? Yes, because they can be written as -2 over 1, -3 over 1, -4 over 1, 0 over 1, 1 over 2, 1 over 1, and so on. So this is true. Last one. Every rational number is an integer. So here I can think of a rational number which is 1 over 2. Is 1 over 2 an integer? It's not. So here the answer is no, or you can say false. Right? I hope this is making sense. Now in the next one, let's see, find 5 rational numbers between 1 and 2. All right, so if we draw a number line, so if I'm drawing a number line, let us suppose that's 0, that is 1, and that is 2. So we have to find five rational numbers between 1 and 2. Between 1 and 2 means we are not considering 1 and 2. We need between that. So I know that between 1 and 2 is going to be 3 over 2. But that's the only one I can think of. So there is a strategy, there is a way to find that, right? So what we can do is, if I write 1 and 2, we have to find 5 numbers, right? So I will take a number more than 5, right? Just to be safe, so we have more options. I can take 6, I can take 7 or 8 or however many. I will take 7 in this case, all right? So when I take 7, I know that for 1, it can be written as 7 over 7 because 7 over 7 is also 1, right? So 7 over 7. Now, to have 7 as a denominator here, this 2 is now going to become 14 because it's 2 times 7 over 7, right? Now, we have so many numbers in between that. So we have, let's write the numbers. We will have 8 over 7, 9 over 7, 10 over 7, 11 over 7. I don't have space. Let's write more. 12 over 7, 13 over 7, and at the end I have 14 over 7. All right. So 1 over 7 is 1. 14 over 7 is 2. And all these numbers are lying in between 1 and 2, right? So these numbers are our answer. And no matter how many parts you're dividing it into, I'm dividing it to 7 parts. That's why I have denominator 7. You can divide it by any number of parts you want. You can divide by 10 and write any 5 rational numbers between that. All right. So that is one way. I can choose any 5 numbers out of these and that could be my answer. But it's always good to show your working, to show them that yes, you know how to solve it. All right. Let's go to the next question. So next question is 0 a rational number? Ooh, 0 is 0. Rational number needs to be in the P over Q form, where Q is not equals to 0, right? But 0 can be written as 0 over 1. So yes, 0 is a rational number. Right, next. Find 6 rational numbers between 3 and 4. We just recently did 3 and 4. 6, I can choose any number greater than that. I'll pick 7 again. So that can be, so we have to do 7 times 7. Right, because this is 3. Previously it was 1, so that became 7 over 7. Now we are timesing by 7 over 7, so it will become 21 over 7. The next is 4, so 7 over 7 will become 28 over 7. Right, so now I can have all the numbers in between that. So I have 22 over 7, 23 over 7, 24 over 7, 25 over 7, 26 over 7, and 27 over 7. And I can choose 1, 2, 3, 4, 5, 6 numbers out of it. Right? So these numbers lie between 3 and 4. Right? Cool. Next one. Find 5 rational numbers between 3 and 4. This is a similar question. I'm not doing it again. This is exactly the same question. Here it was 6 rational numbers. This is 5 rational numbers. Now you stop here and it's you who had to solve it. So pause the video and solve this question. Right? Next one. Find 5 rational numbers between 3 over 5 and 4 over 5. That's an interesting one. So 3 over 5 and 4 over 5, right? I need 5 rational numbers. I'll take a number greater than that or any number greater than that. So I'm taking times 6 over 6 times 6 over 6. Same strategy. We're doing that again. So now 3 times 6 is 18 over 30. And here we will have 4 times 6 is 24 over 30. Right, so now we have numbers in between: 19 over 30, 20 over 30, 21 over 30, 22 over 30, and 23 over 30. So we have 1, 2, 3, 4, 5 rational numbers between 3/5 and 4/5. So this one is 3/5 when you simplify. This one is 4/5 when you simplify. Right. This is the last slide. So here, state whether the following statements are true or false. Every natural number is a whole number. Natural numbers starts from 1, 2, 3, 4, 5. Whole numbers are 0, 1, 2, 3, 4, 5. Right? So yes, because each of these numbers are in here. So yes, every natural number is a whole number. Every integer is a whole number. So every integer, so integers are minus 3, minus 2, minus 1, 0, 1, 2, 3. Whole numbers are 0, 1, 2, 3, 4, and so on. Right? So every integer, these numbers here are not here. So every integer is not a whole number. False. Every rational number is a whole number. Rational number, again, we can think, we have done so many rational numbers now. So we can think, let us say 23 over 30. We recently did that one. So 23 over 30, is that a whole number? No, it's not. So it's a false statement. right? And it's always good to think of these statements and think about natural numbers, whole numbers, or any topic that you're doing. Just think of these questions in your head. It always clarify more, and you understand the topic better. All right, so stay tuned for irrational numbers because that's going to be the next video. And I hope it makes sense. Definitely leave a comment below if you do understand from this, if you feel this is helpful, right? And subscribe. Don't forget to subscribe my channel. Have a good day.